All right, this is notes for myself. I am going to write code to do a RAG system to talk to my data that I created here from my previous example, also some friends and some facts about them. I want to go ahead and talk, basically chat with that data. I did a sample of this by using a simple LangChain RAG system in my previous video on that basic RAG on this file here. But this time I'm going to add few things to it. I'm going to do this using the LangGraph like a workflow, and also how to make memory persistent. So here I'm going to have like a 2-node based system here, and keep track of my history. So let me go ahead and start building my frameworks. So I'll start by saying from LangChain Ollama, I'm going to import the Chat Ollama model. So here I'm going to say Chat Ollama model is equal to, let me see if I still memorize it. It's going to equal to llama. I'm going to use this as very simple one, sample one, 3.2 colon 3b. I usually pretty much use the Qwen3-coder, but the reason I'm using this one is because the Qwen3-coder, it's a Ollama model that also gives you its thinking, its reasoning, and I have not taken care of the part of filtering out the reasoning on this code. So I'm using a smaller model or different model that doesn't reason, so I can just grab its output just for the purpose of this testing. And my base URL is equal to http 11.434. All right. Now I'm going to go ahead and create my main loop. While true, let's put some divider here. And I'm going to ask my question. All right, you enter question. And then period to quit. All right. If question is period, then let's break it out. Okay, so what do I need to do next? Let's go ahead and build the memory state module, class for defining the memory for my state graph. So for that, I'm going to go ahead and bring in from typing, import typed dict annotated. Also, I need to bring in from LangGraph dot LangGraph dot graph dot message. I'm going to import two modules, any message and also the add message. The any message is really just a list, but it's like a type definition that other modules may take advantage of to see what actually is stored, even though it's a list. I'll show that, describe that in a little bit more here. So I'm going to go ahead and create my class of type dict. Basically, here's where I'm going to create the variables or the fields that I want to basically store in my on my class. I can think of this as like a table in a SQL. The type dict basically says, okay, what are the columns you like to put in into this table? So that's the way I can think of it. So I go in here and I want to create messages. So messages is like my notebook that I'm going to keep track of the conversation between the user and the AI, and then it's annotated. Means basically use the following rules. If I want to think of it like that, use the following rules to create my notebook. I want it to be any message. I can again use list here, but I'm using any message because it's more type specific. So any message, comma, and I'm going to say add message. So basically, every time I invoke this, I'm just going to append the new message or the new conversation to this notebook or to this memory for messages. All right, then I'm going to go ahead and track this question itself here. I'm going to go ahead and store the answer. And I'm also going to store the data. Okay, so that's my state graph memory. So now I'm going to go ahead and create a couple of placeholders so I can put everything together. I'm going to create two functions or two nodes, a retriever and assistant. So let's go ahead and do the retriever first. Retriever, and it's going to use the state graph that I just created. I'm going to put pass just for placeholder. And I'm also going to create one for the assistant, which this becomes nodes. So state, same thing. So I can have a instance of my state memory state variables here. Okay, so I have those two nodes. Let me go ahead and now create the workflow. So with that, I'm going to say builder is equal to, let's go ahead and define the LangGraph for the workflow from LangGraph graph. I'm going to import the state graph, the start and the end. These are basically, I guess, pointers for beginning and ending the flow. So I'm going to basically say now use the state graph and use its memory. All right. Now I'm going to add my nodes or the functions to this flow. So builder.add node, retriever, and this is gonna be the function name. I'm gonna have one more node, assistant, tied into the function. Now I'm going to build the flow. Builder dot add edge, start with start. As soon as you start, go to the retriever. You put in the ones that you actually labeled, that this could be called anything. Let's go ahead and from the flow. So from the retriever, so once I get the relevant data comes from the retriever, so from the retriever node, I want you to go to the assistant function. And then from the assistant, once the assistant does its thing, I want to end my flow. All right. So now before I go ahead and store this in a graph, I need to keep track of the memory, saving each step along the way. For that, I need to go ahead and say from LangGraph dot checkpoint dot memory import MemorySaver. The whole purpose of this checkpoint for my own recalling, it's like, let's say you're playing a game. The checkpoint basically every time at any point you like save your state, you know exactly where you were, so you can continue from there on. So that's basically, I'm going to get a instance of it by saying MemorySaver. And then when I build my graph, and I'm going to call it graph, I could even call it agent or something, which will probably be what I will call from in future. But this is just my graph. For a demo, I'll call it variable called graph is equal to builder.compile. And then I want to use the check pointer. This is every time it basically a workflow it starts again, it creates a save for all the variables or the state of the graph at that point. Check pointer is equal to memory. There we go. So I think I'm good with that. So now let's go ahead and what I want to do next is let's go ahead and do the retriever. This is the get relevant. The retriever basically comes from this Qdrant vector.py, which I did in my previous tutorial. This here just builds my vector database, this create vector database. But then here, I also have a function called get relevant. So this get relevant is called when I invoke it, and whatever I pass as a parameter to this function, as when I invoke it, it basically goes and does a similarity search, basically based on the client, which points to the quadrant, the collection name, and the embeddings to be used, what embeddings to use to convert the input query into the floating embedding numbers that I can do my search on. And it tells once you do the search, just retrieve the last three. So that's get relevant is basically what I will use. So I'm going to go down here. Let's bring it over. So Qdrant import, I'm going to say get relevant. So now putting that here, I'm going to go ahead and say, all right, my relevant documents, relevant docs is equal to get relevant. I'm going to call that function. I'm going to invoke it. And then I'm going to pass the question that was entered by the user and that I grab from the state memory. All right. So the question is grabbed, sends over, I get some relevant documents. But now, here's it's an important piece here. Now, once I'm done with this function, you see here when I define my class and I have these variables, when you on a LangGraph, when you call basically a node or a function, when you return, you need to update what is it inside. You need to update one of these variables. What is it this flow updating? So in this particular case, the question comes in. The result is data gets updated. So I'm going to come back here, and it's a JSON object. So I'm going to say data is the one that it's going to be update on the state, and it basically comes from relevant docs. That's all we need. So the docs gets the relevant documents will be stored into data. So now once the flow says what? Go to retriever. Once the retriever is done, go to assistant. All right. So now here I have the question. Here's I have the data. Now I will go to the assistant. All right. For this, what do I need to do? I will go ahead and actually I'm going to go ahead and copy this to the top of the code. All right. Let's go ahead and create a system message first that I will use as a prompt for my LLM. So what do I want the LLM to do or to know? I'm going to say you are an expert in answering questions on facts provided by my friends. Your answer will be short and precise, and you will not explain or give reasoning as to how you got it. I guess I can tweak the wording, but that's basically in a nutshell. It should be good enough to get me going to see what it responds. I may tweak it later. Okay, so now I go to my assistant. So I have the system message. Now I need to use for the AI message, human message, system message stuff. Let's go ahead and bring all of that from LangGraph. So from LangGraph Core.messages, import, I'm going to bring in the system message. I'm going to bring in the human message. This is what I need, but I'm also going to add AI message, which I'm not going to use, but I'll just leave it in there because it just gets appended by default when I get my result back. But let's just leave it in there. All right. So here, what I want to do is first build my prompt. So I have this instruction, but I need to add the data to it. So let's go ahead and build the prompt. So prompt is equal to my let's go ahead and do my system message. All right, so I have my system message goes into the prompt, plus I need to also add the data, and I'm going to basically do as if I'm going to some new lines for formatting purpose, and I'm going to say use the following, use the data, use, or I can just basically say here is the data. And I'm going to go ahead and say the data itself is in my state, right? State.data. So let's look at it. Here, when I return from my retriever, data gets updated, right, on my state. Here, I'm referencing it. So now I'm going to go ahead and invoke the LLM. So I'm going to say response is equal to, I'm going to call my LLM, I'm going to invoke it. All right. So what do I want to do? I'm going to go ahead and send in this prompt, and I'm going to go ahead and send in the prompt, and I'm going to add the messages to it. Data, I'm going to say state.messages. All right. Here is something important I need to take into account. State messages, here is a list. So I can't just go ahead and add prompt to this. This has to also be a list. So I will enclose it into open bracket, close bracket to make it a list. So this now gets basically, so here is the idea. This is my prompt. I'm going to add I'm going to add the data that I got from my retriever onto it, and I'm going to send that to my LLM along with all the messages that I will have tracked as I go along, which basically Graph will just do it for you. We'll just add all the, every time the question answer comes, so I'm going to save it onto it. So what do I want to return? All right. On the return, again, it has to be a JSON object. So based on this state, what am I returning? Well, I'm returning answer, and I'm also returning messages with added, right? Based on the response that I'm getting. So I'm going to go ahead and say answer is going to say response.content. That's basically just the response of the AI part, comma, and I'm going to return messages But then I'm going to say response, and then I'm going to close the JSON object. But response is going, it's really the entire AI message. Here, when I said the AI message, I could have added it, but to here to say it's specific to say it, but response is already the AI message. But here's the thing again, messages is a list. So I need to make sure this is a list. I'm converting that to a list, so it just will just get appended every time I references this add messages. We'll just basically take the response and just adds it to it here. I think I should be good with that. So let's go ahead and continue with this on my main code. So I got all the flow going. Now I'm actually going to initiate and get some results going. So I'm going to say, I'm going to use the streaming. I'm going to say for chunk, I'm going to call it chunk in graph dot stream. Actually, one more thing I need to do. Because I'm doing the MemorySaver, I also need to create like a thread ID. Thread ID, which I'll explain in 1 second. Let me type it in. Thread ID is equal to 1, or I'm going to call it user SK. And then I'm going to say config is equal to JSON object configurable of thread ID and pass a thread ID. So conceptually, so that I can recall all of this MemorySaver, it's like a notebook, if I want to think of it like that, that keeps instances of every time I do a save, right? This config, this part of it is going to tell now I'm going to deal with maybe multiple notebooks. So in this case, I have a user SK, it could be a different user. So for each user, I'm going to create the save memory part. All right, so I defined it there. This is its usage. For chunking graph.stream, all right, so what do I need to send in? So the first thing I need to send in is the question, right? So question is actually the question. No, I need this to be an object. And then I'm going to go ahead and for the messages to start it off, I'm going to say it's the human message. The content is equal to question. Close this. I forgot to say messages. And then this is a loop. But then one more thing, I need to add in my thread pointer. So config is equal to config, which I've called it. And for now, I'm just going to say print chunk. I'm not going to worry about what it responds. So here, the key thing here is initially, the very first time I'm calling it, I'm going to put a question in my messages. And question goes in there for the retriever to get it right from here. And let's go ahead and run this and basically see what happens. So Python LangGraph _rag.python. Oh, no syntax so far. Enter question. Let's go ahead and bring my data so I can look at my data here. I'm going to say who lives in Toronto. Let's see, based on the data, what it will answer. I got an error message. Okay. I already know exactly what it is. The human messages is now the list. So let's go back to my here, all right, you see here, messages is a list. I need to make sure this is a list. So I go back in here, make that a list. So let's go ahead and try it again. I saved it. Let's clear the screen and I'll run it. Let's bring the data back up again. All right. Who lives in Toronto? All right, so it's good. I have exactly what I wanted. If I know this, look at it. I have my retriever here. And I also have my assistant. This is the workflow from the graph, right? This is what I got back from the retriever that it went and called the vector database, and it got the three relevant documents based on that question. And here's the assistant. So now just keep track of this assistant and the answer here. Look what I'm going to do. So now, so that I can kind of tailor down my output, I'm going to say if answer in chunk. So as soon as it sees, I see basically not answer, assistant. As soon as I see assistant, then what do I want to print? I want to print inside assistant. I want to print the content of this answer. So I can say chunk in assistant answer. That's what I want to print. Let's go ahead and see if this all works. So I saved it, clear screen. Let's go back to our data here. All right, who lives in Toronto? And then I can say, who loves rabbits? Let's do one more. Who lives in Holland? Anita is answering the question, who is my best friend? I don't know if it's going to do this one. All right, it picked my the Tony in there too. Now look what I'm going to do. I'm going to say list all questions. See if it remembers it. Look, it numbered it. Now I'm going to say what was my first question? It may come up with something weird here. All right, no, this time actually worked. The reason why I was expecting for it to come with something weird is I have to be careful with these prompts. Somehow, because I am mixing the data, the facts, along with the messages, it may confuse it, and different models may behave differently. So in this case, it just shows it. I'm fine, but that's just something I need to keep as a pointer in case it becomes an issue. Let me go ahead and look at one more thing before I close it out. Let's look at my notes here. So I used Ollama. It says Qdrant 3, but I actually used a different model. I've used the Qdrant. I used LangGraph and my MemorySaver, my check pointer. The flow was from retriever to assistant. And basically, that's basic. Here in my class, I use list, but I use any message and not operator. This needs to change. This should be any message. And then this part also needs to say add messages. All right. I think that should wrap it up. That's it.